Thank you for watching this video on how to use the Hutchison tool tapping calculator. My name is Tom Hutchison and I will be your guide. This will be the first of two videos explaining the tapping calculator. This video explains how to use the tapping calculator when using our follow-along units for parts with strip lifts over 1/8 of an inch. So to begin with, the information in lines 3 through 20 is where we set up the tapping calculator to give it all the information that's required for the calculations. So when you look at lines 3, 4, and 5, these are really lines for our own internal purposes when we set up the tapping calculator for a sign-off print. So that's not lines we'll have to fill in today. Really, the most important stuff starts at line 6. So the very first thing we're going to fill in is tap size. So today's application we're going to use an M8 by 1.25, but you can see there's a drop-down list here, so whatever your tap size would be, you can see there's metric and inch measurements for just all the variety of standard taps, so you would just pick the tap size that you would need. The gear ratio, we're going to skip this for now. We will come back to this once we've done some calculations, and you can see where this will help utilize some information about tap speeds and press stroke needed for tapping. So the next line that is important is line 8, which is press stroke in inches. So in today's application we're going to just use a 10-inch press stroke. If you notice, there's an inch and millimeter measurement for both press stroke and some other measurements here. The reason we have two different measurements for inch and metric is, of course, we have different applications for some metric taps, some inch, and so in this case, because we have a metric tap and an inch measurement, we really need to have metric measurements as well, because the calculator to function either is going to function all in metric or all in inch measurements. So in order to do that, we kind of have a little tapping conversion box here that helps us convert inch to metric measurements and vice versa. So in this case, for a 10-inch press stroke, we're going to go ahead and put 10 inches in here, and you can see the equivalent is 254 millimeters. So we're going to go ahead and put that 250 millimeters in the press stroke box here for 254 millimeters. In the next box, you can see it says fill in for follow-along units only. So this is the calculator that we're going to discuss today for follow-along units, which is for units where you have strip lift of 1/8 of an inch or more. And so in today's application, we're just going to use 1/2 inch of strip lift. So we'll have 1/2 inch in here. And again, because we need to have a metric equivalent of that, if you come down here and put 1/2 inch into the calculator here, you can see it's the equivalent of 12.7 millimeters. So in line 11 we have the equivalent of 12.7 millimeters. Line 12 and 13 we're going to ignore today because we will do a separate video about how to use this for standard tapping units. Lines 14, 15, and 16 again are just like lines 3, 4, and 5. These are really more internal numbers that we use for our own internal calculations for sign-off prints, so we can ignore these for now. Line 17 is the part thickness that we'll be tapping. So this is part thickness, not only the thickness, but if you have an extrusion, it'll be the total height of the extrusion. So this is really a number that's the total height that you're tapping. So today's application we're going to use 300 thousandths of total tapping height, which again, converting that in metric is 7.62 millimeters. So that's what we have in line 18. And then lines 19 and 20, it will be for the pitch of the tap. So in this case, again, it's a 1.25 pitch. So that's what we have in line 20 for the metric. But to give us the threads per inch equivalent, again, we have a calculator down here. So the 1.25 is equal to 20.32 threads per inch. So that's what we have in line 19. All right, so with all this information, this will calculate for us now in lines 30 through 69 all the different gear ratios, how much press stroke will be needed for tapping with the different gear ratios. So we always try to use the lowest gear ratio because it helps us maximize the strokes per minute. But what these gear ratios are basically telling us is 0.81, for example, here is telling us you're getting 0.81 revolutions of the tap for every 1 inch of press stroke, all the way up to 4.91 revolutions of the tap for every 1 inch of press stroke. So in this case, we're going to look at, let's just start with 0.81 to 1 ratio. With this ratio, we would use 13.699 inches of press stroke for tapping. Well, of course, you can see that would be problematic with this application because we only have a 10-inch press stroke, so this gear ratio would not give us enough time to do tapping and then still have time for feeding. So let's look down to line 36 here. So with the 1.36 to 1 gear ratio, you can see we're using 8.159 inches of press stroke for tapping. So that would leave us 1.841 inches of press stroke for feeding on the way up to top dead center and 1.841 inches of press stroke past top dead center for feeding. So this is an equivalent of roughly from 330 degrees to 30 degrees would give us time for feeding. So basically 60 degrees of the press stroke we would use for feeding. So if this gives you enough time for feeding the strip, then this would be an appropriate gear ratio that we could use. But if you felt, oh no, we need to have a little bit more time for feeding, if we went down to a 1.6 to 1 ratio, you can see we're using 6.935 inches of press stroke for tapping. So that would give us a little over 3 inches of press stroke on the way up to top dead center for feeding and 3 inches past top dead center for feeding. So, but in this case, let's just say that the 1.36 to 1 ratio is enough time for us to tap and still have time for feeding. So taking this gear ratio, we can now determine what kind of speeds we can run in strokes per minute. So if we come over to this side of the calculator over here, you can see this chart right here shows all the different tap sizes and the recommended RPM that we would run with these tap sizes. This is all based on mild steels, so like a 1008, 1010 type of cold rolled steel. In this case, so we're going to use a high strength low alloy material. So if you look at this chart up here, we have a note that when running these speeds, again this is for just mild steels, but when we're running high strength materials, expect to run about 2/3 of these speeds. So in this case with a mild steel, we'd be tapping at about 1450 RPM. But again, we're going to use a high strength low alloy material today, so 2/3 of 1450 is about 971 RPM. So we just put in this red box 971, and if you scroll down to 1.36 to 1 ratio, you can see that will run about 36 strokes per minute. Alright, so that gives you an idea what kind of speeds there. So if we stay with this 1.36 to 1 ratio, if we go back up to line 7, which is that gear ratio box, and we go ahead and put 1.36 to 1 ratio in there, what this will do is this kind of recaps in this section here a couple of things for us. One is how much press stroke is required for tapping, which is again 8.159 inches of press stroke, and then also it shows with 971 RPM with the 1.36 to 1 ratio, we can run 36 strokes a minute. So this is the main basis for this tapping calculator, helping us determine press stroke needed for tapping and production speed as far as strokes per minute. I hope this explanation will give you a better feeling of how to use this tapping calculator. Certainly if you have any questions, we would love to hear you, and so just please contact us at 800-332-3230, or you can certainly contact me directly at my email address, which is tom@hutchisontool.com. So this concludes our explanation, and we hope to hear from you soon on applications we can help you with.